Hi, my name is Manettas, and I go by Manettas for short. In this video, I'm going to be showing you how to make a terrarium, which is a self-contained water cycle. This is a craft from the Family Reading and Science program with the Natural History Museum here at U of M, which I've worked of, fortunately, part-time for my work study. And there I'm sort of an instructor, and we teach these workshops centered around water and its properties and its uses and facts about it. And we do this in Detroit libraries, K through 8, and this is just one of the crafts that we do. So the first thing you need for this craft are actually two things: two plastic clear cups. You start by taking one of the plastic clear cups and filling the bottom with pebbles. These pebbles are meant to simulate the bedrock of the earth, which is under all the soil. So once you have enough pebbles to separate for about, I'd say, 3 or 4 millimeters, you're ready to put the soil in. Now, next comes the soil. You want to put in about 3 to 4 inches of soil in the terrarium for the lower cup. The point of the soil is to absorb some of the water, which again simulates the water cycle, and also to plant some of the seeds in, which are going to be lentil seeds that should grow in approximately 3 to 4 days. Now, before we keep going, it's important to talk about some of the properties of water. Now, water can be in one of 3 states. It can be either a solid, a liquid, or a gas. Now, in these 3 states, the difference ends up being the density of the molecules. Water, like all other things, is made of molecules, which are the building blocks of life. This is meant to simulate a water molecule, which is made of atoms. All molecules are made of atoms, which are the very smallest building blocks of life. Well, not exactly the smallest, but that's for a more complicated lecture. And what we have here is an oxygen atom and 2 hydrogen atoms. Now, a lot of people have heard water referred to as H2O, and that's why. You have 1 O and 2 H's. Now, why I bring up this water molecule is that density involves the orientation of molecules with one another. Now, in very dense things, you have a bunch of these molecules very close together. And in not dense things, or in something that's the same but less dense, those same molecules would be farther apart. Now, this is important for the water cycle because in the water cycle, water changes states. The most least dense state is gas, and that's where the molecules are the furthest apart. Now, as these molecules start losing heat energy, they get closer and closer together and condense into a liquid. Then, if they get even colder, they'll become ice. Conversely, if a solid with densely packed molecules has heat energy added to it, these molecules will start moving around more and more and spread further and further apart, getting less and less dense. Now, in the water cycle, water as a solid is ice, and as a liquid, it's water, of course. And as liquid, it'll sit there maybe in the groundwater, in the soil in our terrarium, and as heat energy is added to it, it'll begin to do what we call evaporate. And in evaporation, water goes from a liquid to a gas. And this gas rises, goes up into the atmosphere, and then as heat energy is lost, it starts to condense, which is when water goes back from a gas to a liquid. Now, this liquid forms little droplets that all together are something we're very familiar with, and those are clouds. Now, after a while, enough of this water will condense so that the clouds become oversaturated, and the water falls back down as liquid in the form of rain. And then what happens, of course, is that this liquid has heat energy again added to it and evaporates back up, continuing in this cycle of which, solids are also involved when you think about ice and glaciers and things of that nature. So the next thing we want to do is sort of talk about water in its liquid form, which we find in lakes, for one. And what we're going to do is take a small, round, blue piece of clay, pat it down into a circle, then curl the edges of the circle back up so that we get a sort of bowl shape. And this bowl is meant to simulate a lake. So we're going to take the lake and put it inside of our terrarium. Next, we take a bunch of seeds, pinch them in, hold them underneath the dirt, and add our most important feature, water. We fill up our lake, water the seeds, put the top on our terrarium, and tape it back up. The tape's very important. It sort of illustrates that our water cycle is self-contained and that no new water should be needed to be added. That's kind of like our same Earth, where water has been around since the beginning of the Earth as we know it. And the same water we drink and eat today is the same water dinosaurs used to drink. And there you have it, a terrarium. In 3 to 4 days you should have a plant, and it should self-sustain itself. Continuous cycle of the water in the water cycle. Thanks.